Hi, welcome to today's class. As we continue with our revision, you're so much welcome to this session. So, this is the paper that we had for our midterm exam, and I want us to look at this paper. It's from Udhiro Junior Secondary School. So, I want us to try and solve the problems that we had here. So, I'll be reading the question here. The question, the first number is we work out 1 all over 3 minus 2 all over 9 plus 4 all over 5 multiply by 1 all over 8. Then you're dividing by 1 all over 4. Ignore all this. I'll just be using this one. So I'll go to my working space and we right away begin the work. So I'll divide the section like that, and we have the other section like that. So that number one, we want to work out. That is the instruction, and the fraction is 1 all over 3. We are subtracting 2 all over 9, then plus 4 all over 5. You multiply by 1 all over 8, then you're dividing by 1 all over 4. So this is what we had. I believe that you have a paper with you or somewhere you're writing so that you are able to solve these together. So the solution for this, I will have to follow BODMAS because you have different operations. We have subtraction, we have addition, we have multiplication, and we have division. So let me follow BODMAS so that I can be able to have the right way or the right order of solving this problem. So I ask myself, do I have brackets? No, I do not have brackets. Do I have off? I do not have off. Do I have division? Yes, I have division. So I'll pick the two numbers that are on either side of division. 1 all over 8. I am dividing by 1 all over 4, which is the same as 1 all over 8. I multiply. The moment I replace the division sign with multiplication sign, then I write reciprocal of this. It will be 4 all over 1. Then I ask myself, do you have a number in the numerator that can be divided by the denominator? Yes, it is. 4 can go into 8. So by 4, 1. By 4, 2. So that I have 1 multiplied by 1, it is 1. Then 1, 2 multiplied by 1 equals to 2. So the answer here is 1 all over 2. Then I rewrite my sum, 1 all over 3, this one, minus 2 all over 9. Then I add 4 all over 5. Then I multiply. Instead of writing the whole of these again, so the answer was 1 all over 2. So do I have any other division sign in this sum? No, so I cancel that one. Do you have multiplication? Yes, this is multiplication. And I can come and solve here. I have 4 all over 5. You're multiplying by 1 all over 2. Do you have a number in the numerator that can be simplified with the denominator? Yes, by 2, 1. By 2, you're having 2. So I've cancelled that. Do you still have any other? No, so that my answer will be 2 multiplied by 1, it is 2. Then 5 multiplied by 1, it is 5. So the answer here is 2 all over 5. I go ahead and write this one, 1 all over 3. I am subtracting 2 all over 9. Then I am adding the answer that I got here. It was 2 all over 5. When I am having subtraction and division alone, then I can continue to follow the order. Now I'm done with the multiplication. Or it's also okay to just work this operation once. So I get the LCM of 3, 9, and 5. The LCM of 3, 9, and 5, which is 45. I believe that is the LCM. You can confirm. So that 15 divided by 3, 45 divided by 3 gives me 15. 15 multiplied by 1, that is 15. Subtract this sign. I've taken this subtraction, is the one that was coming from here. 45, I divide by 9, it's 5. 5 multiplied by 2, the answer is 10. Then the next sign that I should write here, it is whatever you had here. So I'll add 45, you divide by 5, that is 9. 9 multiplied by 2 equals to 18. So that my sum will be 15 minus 10, that is 5. 5 plus 18, that is 23. So my answer is 23 all over 45. So I get my answer as that. So this was number 1. Number 2, we look at number 2. I go to that sum and we look at number 2. Number 2, this is what we had. The amount of tax that is paid by Jayden is this amount, 17,695,284. So we want to round off the amount of money to the nearest 10 million. So if I come to my working space, I'll come the amount of money in terms of tax that is paid to Jayden is 17 million. So I write 17 million. You have 695,285. So we want to round off. So the instruction here is to round off to the nearest, round off to the nearest, 10 million. 10 million. So I'll come here and try to identify what is the place value of, because the decimal is here, the place value of 5 is ones, tens, 100, thousands, tens of thousands, 100 of thousands, millions, tens of millions. This is a number I am checking, and because I'm rounding off, I will check the number that is before. If it has reached 5, I add here 1. If it is less than 5, then I leave it like that. So because 7 is more than 5 actually, I'll come and add here 1, so that I'll have 2. Then these other numbers, I turn them to be 0. So you'll have how many zeros? 1, 2, 3, 4, 5, 6, 7. So I'll put 1, 2, 3, 4, 5, 6, 7. So that is your answer to the nearest 10 million. The question number 3. Question number 3 is what we have here. Question number 3 is this one. 3 members in a society shared profit. One member received 1/6 of the profit. Another member received 1/9 of the profit. Question A, find the fraction of the profit received by the third member. So I'll come to my working again here. You're having 3 members in a society shared a profit. One member received 1/6 of the profit, another member 1/9 of the profit. So you're having the first member. So you're having the first member received 1/6. Then you're having the second member received 1/9. So you want to know the third member. So the question 1, the fraction that the third member received. So the secret here is one, that the total profit in terms of fraction is 1. So this one is the profit. This is the profit in fraction before it is shared. So this is the fraction, is a whole number. So the profit as a whole number, it is, or a complete fraction, is 1. So if the first member received 1 all over 6, I'll subtract it from 1, and the second member 1 all over 9, subtract it from 1. Then the remaining is what the third received, because we've been told the first member received this one of profit. This is very, very important, this statement of profit. So I will come and say that the third member received this amount. I take the complete fraction, the whole profit. I subtract what the first member received. I again subtract what the second member received. The remaining is what the third received. So up to that, the remaining fraction out of this, if I remove the first received, then what the second received, then the remaining fraction is what the third member received. So I'll come here and work out this one. Of course, here the denominator is 1. So I ask myself, what is the LCM of 1, 6, and 9? The LCM of 1, 6, and 9. And the LCM, if I calculate, it will be 18. So I take 18 divided by 1 is 18, multiply by 1, that is 18. Subtract 18 divided by 6, that is 3. 3 multiplied by 1, that is the same as 3. Then 18, if we divide by 9, that is 2. 2 multiplied by 1, that is still 2. So that the final answer is 18 minus 3, that is 15. 15 minus 2, that is 13, like that. So the third member received this fraction. All right, received that fraction. Let me just, to differentiate my work, let me put a line there so that you cannot confuse the working here. So that now we go to, this was A. Let us go to part B of that. So if I go to part B of that, let us look at what the question says. If the third member received 13,000, 13,000, find the amount of the profit received by each of the other two members. So here you are told that if the third member, so you've been told that the third member, So here you have the third member received shillings, 13,000. Sorry, supposed to be 3 zeros, 13,000. 1, 2, 3, like that. So I want to know what the first received and what the second received. So I don't know what this one received. I don't know what this one received. So I can come here and ask myself, this is what the third received. And remember, we've gotten the fraction of what the third received. The third member, in terms of the fraction, alipata 13 all over 18. He received 13 all over 18. Now this fraction is the one that you've been told is the same as amount 13,000. 13,000. So I can come here and just cross multiply. I ask myself, what about the first, whose fraction is 1 all over 6? And again, what about the second, whose fraction is 1 all over 9? So I'll come and write here, what about those who had 1 all over 6? I cross multiply. So I'll take this one, multiply by that, then you divide by this, the normal way you normally do the cross multiplication. 1 all over 6, I multiply by 13,000. Then my answer, I divide by 13 all over 18. Is the same as, if I check this one, it is the same as 1 all over 6. I multiply by 13,000. This one, because this is the same as all over 1, this is just the same as, because there is no number that this number 6 cannot go into 13. I can leave it like that. That I have 13,000. I'm dividing by 1 multiplied by 6, the same as 6. So the numerator, the answer is that one. So I'm taking now the numerator, which is this one. I'm dividing by this. So it is 13, 1, 2, 3, all over 6. We are dividing by 13 all over 18, the denominator. Okay, so we do the same thing here in division. This is what we did. 1 all over 8 divided by 1 all over 4 is the same as 1 all over 8. You multiply by reciprocal of this one. So I'll come here and do the same thing, which is 13,000 all over 6. I multiply by 18 all over 13. Then I can see clearly that by 13, 1, by 13, 13 goes into 13 one time. Then you have 1, 2, 3 zeros. I think 6 goes into 18 by 6, 1 by 6. This is the same as 3. So that you see 1,000 multiplied by 3 gives me shillings 3,000. So the first person who had a fraction of 1 over 6 received 3,000. If I go the second, the second, I'll come and still ask myself. So this is the first member. First member received that amount. If I want to get the second one, I'll still come and do the same thing here. If 13 all over 18 fraction is the same as shillings 13,000. This one, if 13 is the same as that, what about the fraction of what the second member received, which is 1 all over 9? I'll come and say 1 all over 9. What about that one? And I do the same cross multiplication. So I take this 1 all over 9, you multiply by 13,000. 1 all over 9, I multiply by 13,000. Then my answer, I divide by 13 all over 18. And you can see, I'll do the same thing. 1 all over 9, I multiply by 13,000. This is the same as all over 1. And because 9 cannot go into 13,000, I just now take 1 multiplied by 13,000 is 13,000. All over 9 multiplied by 1, the same as 9. So this is what now I want to divide. I'll come here and say that 13,000. Let me push it slightly behind so that the sum it will be. Let me put a line here to differentiate the working here. I'm taking 13,000 all over 9. 13,000, 1, 2, 3 all over 9. I am dividing by 13 all over 18. So 13 all over 18. This is the same as 13,000 all over 9. 13, 1, 2, 3 all over 9. I am multiplying by 18 all over 13. And you can see by this 13, 1, by 13, 1,000. Then by 9, 1, by 9, we're having 2. So this is 1,000 multiplied by 2 becomes shillings 2,000. So this is 2,000. Sorry for congesting that. So that is what this is 2000. So the second first member received this amount, and the second member received this amount. So 2000 and 3000, right? So that is what we had for that. Let me open another page here. Good. Let us go to the next one, which is the next one, which is the next question that reads, number 4, express this 0.04 recurring because of these points here as a fraction. So I'll come to my working space. I come here. This is number 4. This question number 4. They want 0.04. You put a dot here, you put a dot here as a fraction. They want me to express as a fraction. Right. Express as a fraction. Express as a fraction. As a fraction. Sorry for this one. Let me put it somewhere here. Good. Somewhere there. Right. So that as a fraction, I'll first of all say let the fraction be letter R. Let the fraction be letter R. So as a fraction is R, but as a decimal is equals to 0.04. This like that. And if these dots just tells me that R is the same as 0.040404, this is a recurring. It keeps on repeating itself. Now, for me to write this one clearly as a fraction, I'll come and ask myself, now, this number, it has two numbers that repeat itself. You can see 0, 4, then again 0, 4. So we have two numbers. So I want to move this decimal up to where the decimal, the number starts to repeat itself. So it's repeating itself after two steps. 1, 2. Again, you start with 0. 1, 1, 2. Then you start again 0, 4. 1, 2, 0, 4. So you can see after two steps, the number here repeats itself. So I will multiply this number, this R, with two zeros, a number with two zeros, which is 100. And what I do on my left, I do it on my right. So how do I decide whether to pick, whether to multiply by 10 or 100 or 1,000 or 10,000? Is I ask myself, it has moved how many steps before, I will have to move how many steps before the number starts to repeat itself. So if it was one step, then I could have just multiplied by 10. But because it is two steps, I'll multiply by 100. So I multiply here by 100. What is 100 multiplied by R? The answer will be 100 R. So I write 100 R equals to what I do on my left, I also do it on my right. What is 0.040404? You multiply by 100. The decimal will move two steps, 1, 2. So it will be 4.0404 are recurring like that. Because this one, that dots here means this number still keeps on repeating themselves. I hope we are together up to that point. Then I now take this number, 100, I subtract what we have here. So I take 100, I minus r, and what I do on my left, I also do it on my right. This number, I multiply by that. Now, what is 100 r minus r? I have 100 r's here, I minus 1 r. So the answer will be 99 r. Then I come here and ask myself, what is 4 point? We are taking 4.0404. I am subtracting this one here, 0.04 04, and so on. If I subtract 4, this will be just turn to be 0, 0, 0, 0. Then you have 4, like that. Therefore, on my left, I have 99r is equals to 4.0, which you can leave it like that. And if it is of that form, I come and now remain with r. Remember, we said that let r be the fraction. If this number is written as a fraction, let it be r, letter r. This, you can pick any letter, but mine I've picked r. So that if I want to remain with r, I divide here by 99, I divide here by 99. So by that, So the r is same as 4 all over 99. So even if you take a calculator and you take 4 all over 9, the answer is supposed to give you a recurring decimal of 0.04040404. Good. So we have that one. Let's go to number 5. Number 5, the question reads, find the least capacity of tank which can be used to fill containers with capacity of 20 liters, 30 liters, 50 and 50 liters respectively without a remainder. So we have this. So we want to find the least capacity of tank that can be used to fill. We have 20 liters, then you have 30 liters, and here you have 50 liters. Now, majority of us, we know that anytime we are having a question that is talking about the least, the largest, the question is either LCM or GCD. But the question is, how do you tell it's LCM or GCD? How am I able to make that decision of choosing whether it is LCM or GCD? Now, the question here, we want to find a container that can be used to fill. So we want a container that can fill this one. So if it's a container that needs to fill 20, 30, and 50, it can't be a container that is bigger than this. You see, if I find LCM, LCM will give me a huge number because LCM will give me a number or the capacity or a size that these containers can fill, not being filled. So, but I'm looking for one that can fill this container. So this will give me a very huge number. This will give me a huge number. But this one will give me a small number, which I will now go with it because I want a small capacity that can fill this one. I need a small container that fills this one. I cannot pick a big container that fills this. If this one is to be filled, it means it's being filled by a smaller container. So I'll get the GCD of this. Come and take GCD of 20, 30, and 50. Then I ask myself, the least number that can divide all of them without having a remainder, 2 can go into 20, can go into 30, into 50. So 20 by 2, 10, 30 by 2, 15, then 50 by 2, that is 25. I ask myself, can 2 divide all of this? No, this one is not divisible by 2. Let me go to 3. Can 3 divide 10? No. Let me go to 4. 4 cannot go into 10. It cannot go into 15 without having a remainder or even 25. If I go to 5, Yes, 5 can go into 10. This one is 10, can go into 15, and also can go into 20. Right, sorry for that. So I have the GCD of this one. So 10 divided by 5, that gives me 2. 15 divided by 5 gives me 3. 25 divided by 5, that gives me 5. Do you still have a number that can divide all of them without having a remainder? I don't think. So the GCD will be 2 you multiply by 5, which is 10. So 10 will be the least capacity that can fill this one. And you can see 10 can fill 20 without having a remainder, can fill 30 3 times without having a remainder, 50 that times without having a remainder. And because you're looking for capacity, I can say it is 10 liters. 10 liters. If we go to the next one, the next question is number 6. Number 6. And number 6, we have this diagram here. So we want to find the values of the angles marked with letters. Okay, so I will try and sketch this one. Of course, I need to use a ruler to sketch this. Right, so the first diagram looks like this. I'll put a line there like that, and you have like that, you have like that, and you have let me take it slightly above so that we can be able to see clearly. I have that, and I have that, then you have another line there, and you have another line. They are all meeting at this particular point. They are meeting there. You have some symbols here that are very important. They have put a symbol for that and nothing else. So here they have put this is where you have your Y. Here you have, before I put these values, let us just now get the angles first. Here they have put 70. Here they have put 40. I put 40 for us. And they have put what other angle? No. So that I need to get this angle. They want me to get this angle. They want me to get this angle. They want also me to get the angle that is here. The angle that is here. So we have the symbol that it's very important here. Now, if I look at this one, I will come and first of all try to fill this diagram using the angle properties. I come and try to fill this angle using the angle properties. So first of all, I'll fill what I know. These symbols tells you that these two lines are parallel to each other. They are lines that are parallel to each other. Sorry. Now, if they are parallel to each other, it means that first of all, if I begin from here, this angle and this, they are vertically opposite. And vertically opposite angles, they are equal. So this one is also 70 degrees. These two angles, they lie on a straight line. So, and you see angles on a straight line add up to 180. So if this one is 70, then this one is 110. And also this one is vertically opposite, 110. So this is the same as that. This is the same as that. Okay, and if this one is parallel, if this line is parallel to this line, then this angle, and this, they are also equal. Transverse angles. Transverse angles. This angle and this, they are equal. Then this and the other one, the same property of this is the same. So even here, it is 110. Also this angle, it is 110. So I'll put here 110. And also this one is vertically opposite, 110. and this one is also 70 degrees. So we filled that one. If I come to this one, you can guess this one. What is the answer here? Vertically opposite. It is the same as here, 40. This is an angle on a straight line. So if this one is 40, all this is supposed to give me 180. So this is supposed to be 140 degrees, of course, and this is also 140 degrees. Then because they are apparent to each other, this angle, and this, they are angle, and also this is the same as that, 140 degrees. So the angle here is 140 degrees, and you can also see this one is 140 degrees, and also this one is 40 degrees. If I want to get this angle, this is a triangle, and you see angles on a triangle add up to what? 180. So if this one is 70 and this one is 10, then what should be the angle here? So that they give me 180. So 70 plus 10, that is 110. If I take 180 minus 110, the angle here will be 70, right? So you can have a reminder of ourselves about the angle properties, right? So the first angle is, so here you are having we wanted here, which is x, not x, this is y. The angle here is y, which is that. The angle here was z. The angle here was k. So this one is k. The angle here is x. So that I think I have all the angles. So I'll say that my y, come here and write that y is equals to 70 degrees. And then my x is equals to x, we've said it is 40 degrees, and the other one is z. Z is equals to 70 degrees, and again k in our case here it is 70 degrees. So you have that one. This was A, this was number 6A. Then now we got number 6B, and again you have the diagram that looks like this. Have a diagram that looks like that. You have a diagram that looks like that. You put a straight line here, and you put a straight line here. But here you don't have this symbol. So these lines, you cannot assume they are parallel to each other. So that if here they put for me 115 degrees, and here they have put for me 70 degrees, they want me to get, this one is 68. Now, this one is 68. I can just begin from one point. 68, these are angles on a straight line. This is also 68. And if these are angles on a straight line, so I'll ask myself, angles on a straight line add up to 180. So I take 180 minus 68. That gives me 112. Again, this is supposed to be 112 degrees. This is also angle on a straight line. So this one will be 180 minus 115. This will be 65. And also this one will be 65. And also this one will be 115. Please remind yourself of angle properties. So because all these things, I'm getting them from there. If this one is 70, also this one is supposed to be 70. And this is angle on a straight line. They're supposed to add up to 180. So all this is supposed to be 180. So if this one is 70, the remaining one is supposed to be 110. And also this one is 110. All right. So we are remaining with the angles that are here. But this is a quadrilateral. And a quadrilateral, the angles on a quadrilateral are supposed to add up to 360. So I'll come and say 110 degrees plus 65 degrees, 110 plus 65 plus 112. I'm adding the interior angles plus the angle that I don't know here. Dash is supposed to give me 180, not 180, but 360. Sorry, 360 degrees. So I'll come and ask myself, I can add all these angles, these 112 degrees, then I subtract from 360. So my answer will be 360. I am minusing. If we add all this, 110, if I add 65, then I add 112. This is supposed to be 287. So if I subtract that one, the angle here is supposed to be 73 degrees. The angle here is supposed to be 73 degrees. 73 degrees. So here is 73 degrees. So you can also guess this angle is also 73. These are angles in a straight line. So angles in a straight line, they add up to 180. So if I subtract from 180, I think I'll get 103 degrees. And also this one 103 degrees. Because it is 180, I subtract 73, and the angle, not 103, supposed to be 107. Supposed to be 107. So here 107 and here 107. So that if I add all this on a straight line, is supposed to give me 180. Right? Believe that one is clear for us. The next one is, of course, the question here, they wanted us to get the angle that is here. This one is x. This is where x is. So my x, the angle x, is supposed to be 170 degrees. So that is supposed to be our answer. The next one is this angle. Sorry for that. We have the angle that lies here. Sorry, a minute. Right. Sorry for that. Number 7. We have number 7. If I read for us, number 7, the question here is use tables, use the square, this is use the square and square root table to solve the following. So here is a good question reminding us of use of square of tables. Sorry for this. We want to use tables. So we want to use tables. This is number 7. Tables of square and square roots. Square roots, a very important topic. Square roots, right? So the first one, A here, and I want to emphasize on this 0.03 75, like that. So anytime I write like that, that is the square. So I want to use the tables to get the square of this number. Of course, square means you multiply a number by itself 2 times. So I'll come in my table. Let me open the table that I have here. I have a table here, and I'll come and get, it's a table of squares. So table of squares, and I check where does my table begins. The table here, we are having this number, and the number above here is the square root, but I want the squares. So if I move above here to see whether I can be able to get that one, squares. So squares begin from these reciprocals. So square begins, the least number is 1, and the largest number in the table of squares is 9.9. The other table is the table of square roots. Okay, now that mine doesn't fit, this is what I do. A very important step here. Now, you can see our table. The table of squares begins from 1, then ends with 9.9. And this number is not found in the table. This number is too small, it's 0.0 something. And my table begins from 1 up to 9.9. So I have to make this number fit. So what I need to do, I will move this decimal in a way that it will lie, the number here will lie between 1 and 9.9, right? So I'll move my decimal, and I need to move the decimal here. How many steps? 1, 2. If the decimal comes here, then my number can be found there. So I move 2 steps, 3.75. Then I multiply by 10. Like writing in standard form, I have moved how many steps? 2 steps. And because it's a negative direction, I will put a negative here, or on my right direction. So this is what I get the square, and here I also get the square. So this one I'll get from the table. This one I read from the table. I read from the table. I'll get, for this one I read from table. So let me go from to the table and check whether I can get 3.75. 3.75. So table of squares, 3.7, 5. I look at here. Sorry, 3.75. 5 is here. 5 is this column. Good. So this is 3.75. So you can see the answer is 14.062. 14.062. So the square of this one is 14.062. Then I multiply. Here just multiply this power, or this number here, and this one. So this one remains. This 10 is the one that I've brought it here. I don't change anything here, but here now I multiply this one out. -2 multiplied by a positive number, it is supposed to give me a negative here. A negative you multiply by positive will give you a negative. Then 2 multiplied by 2 gives me a 4. Therefore, this is what I have. And because it's a negative, I'll move behind my decimal backward this number of steps because it's a negative. So I'll come and write this answer 14.062. Then because a negative, I move 4 steps backward. So let us count 1, 2, 3, 4. So at the decimal is supposed to be there. How many zeros in between? 1, 2. Then here I can put a 0. So my answer is 0.00140062. You see, I've moved backward because it's a negative here. If it was a positive, I could have moved forward this number of steps. So I've moved 1, 2, 3, 4 because it's a negative 4 steps. Let's look at number B. Number B, they want me to solve this one. They want me to solve this one. And this is the square root. Square root. So it's the square root of the number that I have here. The square root of this number. I will do the same thing. Come here and follow the same procedure. Square root, so the symbol here, like that. Square root, the number is 643. So you can see the square of this one, I have not found from the table, I've just worked it in my head. So I'll come and do the same thing here. Square root here, this is 18, sorry. Let me write again. This one was A. That so 18. Not 18. It's supposed to be 86. 8643. So I'll come and put 8643. So that we have that one. 643. So I'll come and ask myself, in the table of square and square root, if I check square root, so this is a square, let me go to square root to see the number in square root. The least number is, this is squares, square root, the least number is 1.0. Let me see, it goes all the way up to 9.9. Then again, we have another table that begins from 10 up to 99. The next one is cubes. So the largest number is 99. All right. So I'll come here and check. This number is too huge because the largest number in square roots, it reaches to 99. So this one is too huge. So again, I have the decimal is somewhere here. I need to move this decimal in a way that it can be found. Now, here when you're getting square root, the number of steps that you move should be the steps that is divisible by 2. Here we moved 4 steps towards right. It's a negative. Or not 2 steps. We moved 1, 2. Even here when I'm moving, I need to move the number of steps that is divisible by 2. So if I move 1 step, 2 steps, if the decimal comes here, 2 steps are divisible by 2 and still 86, I can be able to get it from my table because the table goes up to 99. So I'll come here and say I moved 2 steps, 1, 2. I'll put 86.43. I multiply by, I've moved 2 steps. And because I've moved towards my left, I will just write a positive because this one was negative because I was moving towards my right. So this one I get it from the table, square root from the table. But this one, I do the opposite of this. Here we multiplied by 2. So here I will divide by 2 like that, right? So I come to my table and I check 86.43. Let me see whether I can get. So 86.4. 4 is here. This is 0.4. 86.4. which is 2952. So it is 9.2952. 9.2952. So I'll come here and write 2952 as this is not decimal there. 2952, and now we had 9 point, the first one there, right? You can see it is like that. 29, it is 9 point, all these are decimals. Here we have 4, 2952. Then the last number is 3. I check 3 in the last column. I'm having 16. So I come here and add. We add 16 from the farthest point here. So I add 16 and see what is my answer. This is 8. We have 8. We have 6. We have 9. We have 2. Then we have 9 point. So that is what we have from the table. I multiply this one by 10, 2 by 2, 1 by 2, 1. So this is important because if you move a number that's not divisible by 2, it will give you a problem here. So 1 divided by 1, it is 1. So I'll just move one step. This is 9. This is 9. I'll move one step. Here it was a negative. I was moving towards my left. So it's a positive. I'll move one step towards my right. So my answer will be, if I move one step here, like that, the answer will be 92.968. So you have your answer like that. So I have solved that on the square root of that number, right? The square root of that number. Lastly, let me read the last one, which is getting this. This is C. We were getting square root of 0.00414. I do the same thing. This is still the square root. So I'll ask myself, I need to move the number of steps that is divisible by 2. So if I move 1, 2 steps, the decimal will be here. But my table cannot able to read zeros. So I move 1, I've moved 1, 2, 3. Yes, the table begins from 1, but you see, I've moved 3 steps. 3 steps is not divisible by 2. So I move 4 steps. So I move my decimal here. 1, 2, 3, 4. So I'll come and say 41.4. I multiply by, I've moved how many steps? 4 steps. And because it was towards my right, I'll put what? A negative here. So this one I read from the table, but this one I divide by 2 because it is square root. I hope we are okay there. So in my table, I come and read square root of 41.4. 41.4. Square root of 41. 41 is here. 41.4. 4 is here. 41.4. So 41.4 somewhere here. So I'll come and pick 6.4343. So I'll come here and write 6 point. So the square root of this one is 6.4343. 6.4343. And I multiply by 10. By 2, 1, by 2, negative 2. So the numerator here is negative 2. And if it is negative, I'll move towards my left. How many steps? 2 steps. So I'll come and say 1, 2. Somewhere here. So I put a 0 there. So my answer will be, here you have a 0, so it will be 0.064343. So that is my answer.